Good morning! I figured out a way to encode videos into iterations of the Baker's map. This is Bad Apple playing on the Baker's map. In this video I want to share what this is, why it's mathematically interesting, and what kind of neat trick I'm using to make this work. In very basic terms, the Baker's map is a function that I can apply to a set of points in the unit square multiple times. I made a little website for me to explain more precisely, so I can place a few points on the unit square, maybe making a fun pattern, and then I can run a Baker iteration where the square first gets squished and then cut in half and put on top. I can run another iteration and the same thing happens again. And as you can see, the points inside the square kind of get mixed up. And after just 12 iterations, you can see that the points in this square seem to be kind of distributed randomly now. Of course, the Baker's map isn't random. In fact, it's fully deterministic. If you run it twice on the same points, it always produces the same points after 10 iterations. It just kind of looks like they get mixed up really well. And we can quantify this in mathematical terms, but to me, I think the fun thing to do with this is to hide images that appear after a set number of iterations, which we can do because it's deterministic. So for example, I picked these 112 points so specifically so that when you run the Baker iteration for 5 times, it produces an image of, can you see what it makes? 2 more times? Maybe you can see it now. A smiley face. Isn't that cool? And we can do this because we can just simply reverse the iterations, because actually the Baker's map is reversible. When you apply it, no information gets lost. It just kind of gets scrambled. So we can just run it in reverse and produce a smiley face. But actually, with these points, I did something even cooler. I did it so that after 10 more iterations, they actually produce another image. So how did I do that? So to hide multiple images after each other in the Baker map iterations, we need to first kind of understand what the Baker's map actually does to points. Right now, I've only shown you pictures and animations, which are nice, but they don't really give you any insight into how it works. One way to get that insight is to look at the Baker's map in binary. So I added this view to the website where you can place a point down and you see its binary representation on the website. So I can drag it around and even apply the Baker's map and see what it does to the binary representation of that point. I'm just going to run the Baker map a few times and maybe you can see what happens to the binary representation. As you can see, the binary representation seems to kind of shift. For example, if I highlight this string in the x-coordinate, it seems to always move left. And in the y-coordinate, things seem to shift to the right. And importantly, the digits disappearing on the x-coordinate seem to be appearing on the y-coordinate. One way to think about it is that the y and x-coordinate together make one big long number, and every time you iterate the Baker's map, it just kind of shifts the number in that direction. In this case, the y-coordinate kind of needs to be read from this side, and the x-coordinate needs to be read from this side, but the analogy kind of works. And using this representation, we can hide animations inside the Baker's map. So for example, maybe I want my x and y-coordinate to both start with a 0 after 3 iterations. Then I just hide 2 zeros in 3 iterations time, and I let the 3 iterations play. 1, 2, 3. And now the Baker map transformed the point, which originally started with 2 1s, to a point whose y and x coordinate both start with 0. And using the same idea, I can transform points at certain time steps, so after a certain number of iterations, to points where, say, the leading first 6 bits line up to points where I specifically choose them, maybe to resemble some kind of image, like frames of a Bad Apple video. So that's what I did. Here come 1,000 points, moving 80,000 times under the Baker's map, forming an image of the music video of Bad Apple on every 12th iteration. The every 12th iteration comes from the fact that I use 6 bits to represent the x and y coordinate. You could of course use more, but then it just takes a bit longer. Enjoy!
こともまだ知らないの思いが蓋を開けたのなら